Okay, so yesterday I didn't quite finish, and then I went off and finished off camera. Basically, um, what I was doing was almost right. There was like a tiny, well, substantial bug, but basically here I had this check where, so this is the version where I was actually, the computer had a save state, and I was saving it and storing a saved version in the queue, and the problem with what I was doing, it turned out, was that here I had this if statement where if, checking whether the place I go is visited or not, and then after I add it to the queue, um, I go back, this anti-value and go back. Problem was that in the else, I didn't have that go back logic, and so that screwed everything up. And so I added that go back logic, and then it worked, but I wasn't filming then. And then in the second part, they just wanted you to find um, basically what is the furthest point from uh, from where the oxygen source was. So what I did is I ran the computer, and then I got that computer where like basically it was at that place. And again, I just did a very similar breadth first search, just tracking what is the furthest number of steps uh, that I was able to go away, and that worked. And so the part two was actually pretty very similar to what I did in part one. It required only minor changes, um, and uh, so that's that. I feel bad that I didn't finish it on camera, but I did finish it. You can see it on GitHub, or I just showed it to you. And hopefully today I won't have those kind of problems. Um, but as always, I am tired. I'm always tired. If only it would start at like 5 p.m. or something like that, then that would be easier. Let's see if I can do this. Whoop. That's good. And then I VS Code, and I do it like that. And look, they're side by side. That's pretty cool, huh? So we'll see how long that lasts. And 3, 2, 1, go. Okay, but you're 3/4 of the way through the gas giants. Now your round-trip signals take 5 hours. That signal quality is quite bad as well. You can clean up the signal with flawed frequency transmission algorithm FFT. So input FFT takes a list of numbers. The signal you received, each number single digit data like that represents that. FFT operates in repeated phases. Each phase, a new list is constructed with the same length input list. New list also uses input for the next phase. Input of the new list is built by multiplying every value in the input list by value in a repeating pattern and then adding the results. If the input list were that and the pattern for a given element were 1, 2, 3, the result would be 9 times 1 plus 8 times 2 plus 7 times 3. That with each input element repeating thus the only one digit. Then the only one digit is kept. While each element in the output array uses all the same input array elements as a repeating pattern, so which the base pattern is then repeat each value in the pattern a number of times equal to the position in the output list being considered. Repeat once for the first element, twice for the second, 3 times, and so on. So the third element of the output list is being calculated. Repeating the values would require applying the pattern, skip the first value exactly once. In other words, offset the whole pattern. So the second element of the output list would be the phase is complete output list is needed. Below 4 phases within each phase, each output digit is calculated a single line with the result far right. Each multiplication is 1, 0, 1. Okay, so this is not, seems like it's not that complicated, except getting it right, which is complicated. That's fine, and this is going to give me an iter tools, and so we want to def FFT, which a list of numbers, so numbers, which is a list of int, and I think it's going to return a list of ints. So FFT operates in repeated phases, and each phase is constructed. And after 100 phases of FFT, and let's just say, let me do this, FFT phase, and let's pass in a phase ID, which is an int. And okay, so what I want to do each phase, a new list is constructed for the same input list. New list is also used with the next phase. So each element is built multiplying every value by a value in the repeating pattern. And so def pattern phase ID int, and it goes to an iterator of int. So if you import this iterator, so let's get that pattern. And so what is the pattern? Repeat once, and while true, for blank in range phase ID. So base pattern is 0, 1, 0, -1. Repeats value number of times is equal to the position in the output list being considered. Repeat position in the output list. So multiply every value in the input list by value in a repeating pattern. Okay, so it's not actually phase ID. It is which output elements. So let's output elements for blank in range output elements yield 0, yield 1, yield 0, and yield -1. And we're going to want to skip the first, but we'll do that later. So FFT phase, so output equals this for I number in enumerate numbers. And I don't think I actually need phase ID. I'll get rid of that. So for I number in enumerate numbers, pat equals pattern I plus 1, next pat, so we want to throw out the first element. And then what I want to do is I want to say pattern for given 1, 2, 3, and then I want to do and I want to multiply it, and then only the one digit is kept. So for actually I don't need number, so let's just say n equals len numbers for I in range n, next pat, for pat I, number I in zip, pat numbers. And then I want to sum them up and then keep the one digit. And so value, let's say total equals sum pat I times number I for pat I, number I in zip pat numbers, and output dot append total mod 10, that's just the last digit, and return output. So that seems right. So let's run day16.py. Some of these didn't get indented properly, which is weird. Okay, and now let's so let's say FFT phase 1, 2, 3, 4, 5, 6, 7. Let's see if I understood the directions correctly. And I did not. So that's good. Print total. Let's try this again. So it's saying -4, -8, 12. Okay, so I'm totally doing it wrong. So let's say x equals pattern 1, next x, next x, next x, next x, 1, 0, 1, -1. X equals pattern 2, next x, 0, 0, 1, 1, 0, 0, -1, -1. So that seems right. For I in range n, pat equals pattern I plus 1. It's pat totally sum, pat times I times number times I. Let's say values equals list zip pat numbers. Print values. Total equals sum of p times n for pn in values. Print total. Okay, so let's try this one more time. FFT phase. So we have 1 times 1, 2 times 0, 3 times -1, 4 times 0, 5 times 1, 6 times 0, -1 times 7 plus 8 times 0 equals 4. So why do I get -4? 1 -2 plus 3 2 plus 3 is 5, -6 is -1, -7 is -8, but they have 8. That's okay. I feel like I'm doing the right thing, although oh, you know what the issue is? Only the ones digit is kept. Okay, I think I see the problem. The problem is that ones digit is not mod 10 if it's negative. Ones digit and int goes to int. If n is bigger than 0, return n mod 10. Otherwise, return -n mod 10. And so now output append ones digit total. So I think that's the issue. 4, 8, 2, to 6158, and then I do FFT phase of the previous 34040438, and then do it again, and I get 034. Okay, after the first, here are the first of a list after 100 phases. And so let's say that raw equals this, numbers equals int c for c in raw, and then I want to, after 100 phases of FFT, what are the first 8 digits in the final output list? So for blank in range 100, numbers equals FFT phase numbers, print numbers 8. Is that what it said? The first 8? Yeah, after 100 phases. Okay, so let's run this. Is this one of these things where I'm doing it too slow? Nope. Three oh 3005, no, 3055034. Okay. Typed it wrong so many times. Here's 30550349. Let's submit it. That's the right answer. Continue to part 2. Now that your FFT is equal to the real symbol, the real symbol is your puzzle input repeated 10,000 times. Treat this new signal as a single input list. Patterns are stuck as before. The first 7 digits also represent your message offset. The message offset is the location of the 8-digit message in the final output list. Specifically, the message offset indicates the number of digits to skip before reading the 8-digit message. For example, the first 7 digits were 1, 2, 3, 4, 7-digit message would be the 8 digits after skipping that. Or if the message offset were 7, final output list for that, the 8-digit message would be this. Message would offset would be 7-digit number, not 1-digit number. 7. Here's the 8-digit message in the final output list with 1,000 phases. The message offset has been highlighted with the image repeated 10,000 times. Let's try and put this. First 7 digits of your initial input so don't also represent the message offset. So 1, 2, 3, 4, 5, 6, 7. So that means that offset equals this. And now obviously I'm not going to be able to run this thing repeated 10,000 times. So that's not going to work. So let's think about how we can be clever. Now repeated 10,000 times. So, you know, this is like, it's going to be like 6 million. So 6 million numbers long. So that means that each phase is basically 6 million times 6 million, which is too much. So let's think about how we can be more clever about this, which is that um, the message often the number digits skip before reading the 8 digits. Um, so we only want um, eight, you know, we only want 8 specific digits. Um, and now each of those digits is going to require the entire previous pattern. Um, so like if I have, well, let's just say I just want the first digit, for instance. The first digit is going to be, um, that first pattern times uh, everything that came before. Um, so those patterns are going to be, 1, 0, minus 1, 0, and then 1, 1, 0, 0, minus 1, minus 1, 0, 0, and then so on. So like just for instance, it's not the right thing. If I say mega equals numbers times 10,000, um, and if I try and run just even one phase on mega, that's going to be 10,000 times 10,000, which is like 100 million operations. Um, and it's going to take, um, way too long. It's not 10,000 times 10,000. It's 10,000 times 600 times 10,000 times 600. So that's no good. So, um, so there's got to be something smart we can do. And the question is what it is. Um, again, let's think about it. Let's say we just wanted the first digit. The first digit of the 100th phase is going to be that fixed pattern um, applied to the 99th phase. Um, yeah, so this isn't even going to run for one phase. So, um, So let's think about this. First pattern is 0, -1, 0, 1, 0, -1, 0, 1. So that's, S 3 plus S7 plus S11 plus dot 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 minus S1 minus S5 minus dot dot dot. And then the second one is 1, 0, 0, -1, -1, 0, 0, 1, -1, -1. So that's S1 plus, let's see, it's actually S0 plus 1, 2, 3, 4, 5, 6 plus S7 plus S8 plus S13 plus S14. No, here 1, 2, 3, 4, 5, 6, 7, 8. Should be 8 plus S9. 0, 1, 2, 3, 4, 5, 6. No. 0, 1, 2, 3, 4, 5, 6, 7. 8, 9, 10, 11, 12, 13, 14, 15, 16. That minus S3 minus S4 minus S10 minus S11. So each one is going to have this different pattern. And let's see if anyone has solved it. First 100 users get both stars. Okay, so only 7 people have figured out how to get both stars. So that means it's hard. So it can't be something simple. It's got to be something really hard, because otherwise someone would have figured it out. And I don't think they brute forced it. There must be like some difficult trick. All right. Well, it can't be interesting to watch me stare at this website, and I'm not like writing any code, and I don't have any ideas right now. So I'm going to stop streaming and just go off and think about this because I don't have any ideas, and I can't imagine it's interesting to watch me sit here and not have any ideas. So maybe I'll figure it out at some point. Maybe I won't. Um, but I'm not gonna sit. It like it can't be interesting to watch me um, stuck and not doing anything. So I'm not gonna stream me not doing anything.